Hello, my dear students. How are you? How are you, my dear students? So, hope you are doing well and you all are listening my classes. And now, today, today we gather here to discuss, as written in the whiteboard, some organic reactions. Okay, and these organic reactions which we will going to discuss now are very important for your entrance exams after plus 2. It may be after plus 2, it may be after your BSc degree, or it it will be very helpful to crack you some typical questions in any chemistry related exams. It can be any professional exams, any job oriented exams. Okay, it can be any state level teaching recruitment exam. It can be any civil service exam of state level or central level. Okay, so without wasting time, let's move. And before starting my classes, as I told in my previous classes, to please subscribe my channels. Okay, and please write your comments in the comment section, and please share this channel with your fellows, with your friends. Okay, with your friend circle. And if you do have any queries, any doubts, please ask these queries and doubts without any hesitation in the comment box, so that I will get your questions and I will try to answer these questions at my level best. Okay, so first of all, today we are going to discuss a specific name reaction, that is Perkin reaction. What is Perkin reaction? Perkin reaction. And my dear students, please keep your notebook handy, otherwise you all forget this. Write down these notes I am writing on the whiteboard by pausing the video. Okay, so what is the Perkin reaction? Let's have an general scheme of the Perkin reaction. What is this? What is this? This is benzaldehyde. This is benzaldehyde. This is benzaldehyde. This is an aromatic aldehyde. This is an aromatic aldehyde. Okay, it reacts with what it reacts with. I write it here as like this. And what is the compound? What is the compound? This compound actually, basically, I have written the hydrogen bonded to the carbon atom, and I am showing these single sigma bonds. Okay, I am not writing this hydrogen as CH3. Rather, I detach the bonds. Okay, and I clearly write down these bonds. Why? Because the total compound is nothing but, this is called acetic acid anhydride. Acetic acid, this is known as acetic acid anhydride. Why it is called acetic acid anhydride? Because if you add water with this anhydride, you will get acetic acid. So it is the precursor anhydride of acetic acid, so it is called acetic acid anhydride. Okay, so this carbon atom, as I told in my previous class, I will provide link in the description box. So it is the alpha carbon, because if you regard this carbon atom as the functional group, functional keto carbon, then the extreme neighborhood of this carbon atom is that carbon atom, and that carbon atom is called as alpha high carbon. Similarly, this carbon can also be called as alpha carbon. And with this alpha carbon, there are total uh, here again hydrogen will be there. So total 6 hydrogens are attached. So this total compound, this compound certainly contain total 6 hydrogen atoms. Okay, so and treat this with a acetic acid acetate ion in presence of acetate ion. So what kind of carboxylate ion you will take? You will take this carboxylate ion which is analogous to to this anhydride. If you take the formic acid anhydride, you should have the format ion, but formic acid anhydride doesn't give this reaction. Why? Because formic acid anhydride doesn't have any alpha hydrogen. So the acetic acid, the anhydride, not only acetic acid, the anhydride you take should contain more than one alpha hydrogen atom, at least two alpha hydrogen atom. The anhydride should contain at least two alpha hydrogen atom, and you should take the corresponding carboxylate ion of this anhydride, of this acid anhydride. Okay, here we take acetic acid anhydride, that's why we take here acetate. So what will be the product? The product will be CH double bond CH bond C double O H. So it is called cinnamic acid. It is called cinnamic acid, and the acetic acid functional group is the major functional group. So it is the alpha carbon, it is the beta carbon. So look, there is an unsaturation between the alpha beta carbon, so it is an alpha beta unsaturated acid. Alpha beta, the double bond prevails between the alpha carbon and the beta carbon, so it is called as alpha beta unsaturated acid. Alpha beta unsaturated acid, and the name of this reaction is the beta carbon atom contains the phenyl ring, and if you get the 1 2 3, so 3, this is known as 3 phenyl, a phenyl ring at the 3 position. So 3 phenyl or 3 phenyl acrylic acid, this is called as acrylic acid. 3 phenyl acrylic acid, or it can also be called IUPAC nomenclature. What will be the IUPAC nomenclature? 3 phenyl 3 phenyl prop 2-enoic acid. Okay, so actually this is the acrylic acid. This is the acrylic acid. What is the acrylic acid? CH3, oh sorry, uh, CH2 CHC double H. This is the acrylic acid. This is the acrylic acid. So this is the acrylic acid, uh, and here one hydrogen atom is substituted with the phenyl ring. So this is called 3 phenyl acrylic acid, or beta phenyl. You can also say beta phenyl acrylic acid. Okay. So what will be the definition of the Perkin reaction? I will go for the definition. Write down the definition of the Perkin reaction. Write down the definition of the Perkin reaction. This is nothing but the aldol type condensation reaction. What type of condensation reaction is this? This is the aldol type condensation reaction. The aldol type condensation reaction the aldol type condensation reaction between an aromatic aldehyde between an aromatic aldehyde with an with an aliphatic acid anhydride aliphatic acid anhydride containing containing two alpha hydrogen atoms containing two alpha hydrogen atoms presence presence of its carboxylate ion in presence of its carboxylate ion to produce to produce beta acrylic acid to produce beta acrylic acid is said to is known as is said to be or is known as the Perkin reaction. So it is nothing but a condensation reaction. It is nothing but a condensation reaction. It is nothing but a condensation reaction. Okay, so now we're going to discuss the detail of the mechanism of the condensation reaction. Now mechanism, and please write down the definition. I am giving you time, so please write down the definition by pausing the video and by zooming the video. Okay, so mechanism is very easy. So what will be the mechanism of Perkin reaction? First, the acetate ion. This is the step 1. The acetate ion snatches one alpha hydrogen of the acetic acid anhydride molecule. Snatches one alpha hydrogen atom of the acetic acid molecule. CH3. Okay, and you can say that this anion is resonance stabilized with its neighboring carbonyl carbon, so it is very stable. So what will be the step 2? This is the stabilized carb anion. The carb anion formed is resonance stabilized. The carb anion formed here is resonance stabilized. So what is the second reaction in the second step? In the second step, step 2, now the aromatic aldehyde will come into the picture. The aromatic aldehyde will come into the picture. CO, C double bond O, CH3. All these are reversible reaction. CO, This is CH3. Okay. Now, now step 3. Now the so it becomes OH, and again the acetate ion will form. So the acetate ion is here. The acetate ion acts as the base actually. Acetate ion acts as the base because at first base catalyst. At first in the first step it snatches the H plus ion. So this acetate ion acts as the base. Acts as the base. Okay. So what will occur in the step 4? What will be occur in the step 4? In the step 4, here one alpha hydrogen is still alive. Here again, the acetate ion takes this left hydrogen plus ion and okay. Now if you hydrolysis this product, then if you hydrolysis this product, then what happen? Then the beta, final step, the our desired product will be formed. Our desired product is the beta phenyl acrylic acid. Beta phenyl acrylic acid. This is our desired product. Beta phenyl acrylic acid. Okay, my dear friends. So this is all about the Perkin reaction. You all see the Perkin reaction. You see the general scheme of the Perkin reaction. What happened in the Perkin reaction, and you all see the definition of the Perkin reaction and the detail of the mechanism of the Perkin reaction. So hope you all enjoyed, and this is the very important, and it is very noteworthy that the Perkin reaction is very important, and it is frequently asked in different kind of exams like JAM, that is the entrance exam for IIT after your graduation. Okay, the NEET engineer entrance exam for engineering, medical, etc. Okay, so my dear student, if you do have any queries, please write down in the comment section. I will provide you all. I must try to solve your problems, solve your doubts. Okay, and please subscribe my channel and share it with your friends. Okay, so today we will stop here, and hope you all enjoyed, and we once again meet in our next class. Okay, till then, goodbye.